Alright, today we're going to be multiplying complex numbers. Now, every single complex number can be written as z equals a plus bi. Remember that I is the imaginary unit. I is going to be equal to the square root of -1. And I has the interesting property that when you square it, you get -1. So remember that I squared is always going to be equal to -1. Now, when we write complex numbers, we're going to have a plus bi, and it's important to remember that a and b are going to be real numbers. So when we multiply complex numbers, we'll often have two scenarios. Either we're going to be distributing, like the first example, or we're going to be using the FOIL method, like in the second example. But doing this first example, all we're doing here is we're going to be distributing 6i to everything inside the parentheses. So I'm going to be multiplying 5 by 6i, and then I'm going to be multiplying 2i by 6i. So the first thing I'm going to do is I'm going to multiply 5 by 6i. And when we multiply imaginary terms, we always treat I like a variable, just like if it was x. Okay. So 5 times 6i is going to give me 30i plus, and now I'm going to multiply the 6i by the 2i, and I'm going to get 12i squared. 12i squared. Now, whenever I have an I squared, I know that I can always replace it with a -1. So when I write my final answer, I'm going to keep the 30i the same, but I'm going to replace the I squared with a -1. So I'm just going to replace that with a -1 in parentheses. So now I'm multiplying 12 by -1, and I'm going to get 30i minus 12. And that's going to be my final answer. So I've simplified all I can, and what I'm doing is I'm replacing I squared with -1 whenever possible. Okay? So the next example is going to be done using the FOIL method. And this is because I have two terms right here, and I have two terms right here. So starting off with the first two numbers, I'm going to have 6 times 2. 6 times 2, when I multiply those, that's going to give me 12. And then I move on to the outer two numbers. So I'm going to be multiplying this 6 by this 3i over here. So I'm going to connect those. 6 plus 3i is going to give me 18i. So I'm going to write down plus 18i. Alright, so then the next thing I have to do is I have to multiply the inner two, which is going to be 2i times 2. 2i times 2. And when I multiply those, I'm going to get 4i. Okay, and then L is the last letter. L just stands for last, so I'm going to multiply the 2i by the 3i. So I'm going to connect the 2i with the 3i, and when I do that, they multiply to give me 6i squared. 6i squared. Okay, so there are two things I need to simplify for my last step. I need to combine these I terms, right? Because the 18i and the 4i are seen as like terms. We can add those together. I'm going to bring down my 12. And when I add 18i and 4i, I'm going to get 22i. 22i. So then, for my last term over here, I have 6i squared. Well, I'm going to replace the I squared with a -1. So when I write this down, I'm going to keep the 6 the way it is, but I'm going to exchange the I squared for a -1. So I'm going to put that in parentheses. So now, when I multiply 6 times -1, I'm going to get a -6. So I have 12 plus 22i minus 6. Because that -1 is going to turn this into a -6. So then the last thing I have to do is I have to put the real numbers together and keep the imaginary number the way it is. So for my last step, I'm going to have 12 minus 6. That's going to give me 6. So my final answer is going to be 6 plus 22i. And that's it. So whenever you have two complex numbers, let's say z1 and z2, and you multiply them, you're always going to get a complex number in the very end. So if I multiply two complex numbers, I'm always going to get a complex number as a result. So I hope that helps out.